So hello, you're welcome. I was waiting for someone to join, but since he's unable to join, we can't. Sorry, we can't still be waiting for him. Right, we'll have to carry on with whatever we are doing. So, hey, Clement. All right, Clement, if you can unmute. Okay. All right, that's fine. So I believe we can start our meeting. But before we start our meeting, can we pray? Heavenly Father, we thank you for this meeting. We pray that you teach us and you lead us to understand whatever we study today in Jesus' name. Amen. Amen.
Amen.
Okay, before I proceed with anything, does anyone here remember what you did last week? Right? If you remember what you did last week, you can raise your hand and speak. Does anyone, or how many of you were here last week? All right, I see four Sinama. I see Emmanuel Adom. All right, so Emmanuel, can you share with us what you learned last week or what you remember? Right, we'll be building up on what we did last week. And if you could share with us what you learned, I would really be grateful.
Okay. Last week we were going through how to use some of the libraries like NumPy, Pandas, Matplotlib, and Seaborn. Yeah. So that's what we did. We used the NumPy. We used it to create some arrays. We did some manipulations. We did like operations on it.
Oh,
And
okay. All right. All right, that's fine. Thank you very much. So today we'll be looking at preparing data for modeling, right? As data analyst and data scientist, one of the crucial elements in your work is data cleaning, right? If you don't clean your data well, you are going to get a wrong insight or wrong analysis. So I will be sharing my screen in a bit. Right. If you can see my screen, please let me know. Can you see my okay, I don't think it's showing. Okay, oops. Can you see my screen? Hello.
Yes.
All right. Wonderful.
Yes, please.
Okay, great. All right, so we'll be starting. Let's start from. All right. No. All right, sorry. Okay. Yeah, so we'll be looking. Okay, a minute before we start, I think I have to do something. Okay, it's already recording. Okay, then we can proceed. Yeah, so as I was saying earlier on, we'll be tackling why data preparation matters, right? We'll be tackling data preparation. And you ask yourself, why is it that data preparation matters? First of all, raw data is rarely model ready. What this means is anytime you take data from people, it comes with diverse challenges. There are some people, when they are filling forms, they leave some spaces. have you noticed there are times they ask some questions and maybe they are not comfortable with it, so they don't answer, right? Let's say they will say, don't ask a lady her age, right? If you ask her her age, she might not indicate it in the form. So these are some of the challenges we encounter when collecting data. There are some people who don't fill in the form. There are some people who fill the form twice, and there are some mistakes which arises from the form. So what that will do is it will misalign your analysis. Any analysis that you do, you are not going to get a better results, right? That's why they say raw data is really model ready. I'll explain what a model is and all, although that's not in the focus for today. But I want us to have a certain level of understanding, right? Because it's very, very important for as people learning data science to understand the concept, right, rather than just the code. So yeah, raw data, sorry, in case you have a question, right, let's say as I was explaining a concept, you didn't understand the concept, please let me know, right? You can raise your hand, right? I can check from the chat section, or you can unmute and let me know. So you are on mute and you let me know that you don't understand maybe A, B, C, and D, and I go on to proceed. Right. My name is Jim, so you can call me Jim. Then you just pause me in my tracks. And please, are we clear? Hello, hello. Eh, Let me
Hi.
see. Yeah. Okay. Okay. So you're all here. Okay, that's fine. Yeah, so as I was saying earlier on, real data, it has missing values, it has duplicate outliers and all. So we have to ensure that we handle them before it will be model ready. And they say garbage in, garbage out. If you give a model a poor data set, right, what will happen is the output will also be a poor result. It will not be able to make the right predictions, right? You realize that there are sometimes you ask ChatGPT questions and the answer is giving you are wondering, what is this? Like you are just asking yourself, what is this? Right? That's as a result of poor data in some field, right? Not everything, but so far as there is bad data, there is going to be bad performance of the model. And I've elaborated this earlier on that most machine learning project, data science, data analysis, the heavy lifting job is in the data cleaning. Many people spend time in data cleaning because if you clean your data and it is well, it's easy to make predictions, right? So one thing I'd like you to take from this session, right, to understand better is data cleaning is very, very important. Data cleaning is very, very important when you are performing um, a data analysis project or data science, AI. Data cleaning is very important. Right. So the goal is to provide clean, consistent, and informative data. Right. So we can move. Okay. All right. So at the end of this session, what I'm hoping for is we'll understand what missing values are, what outliers are, how to deal with missing values, how to deal with outliers, what it means by encoding categorical variables, scaling numerical features, perform some EDA, right? EDA is exploratory data analysis, then summarize insights from data. All right. So one thing I'm really looking forward to doing in this session is breaking down the concepts bit by bit. We read the evaluation form you guys filled, and one thing we realize is most of you are beginners, and as a result, some of the concepts or some of the things we're speaking about was a bit foreign to you, right? So one thing I'm hoping to do is I'm hoping to break down the concepts to the smallest units, some will say to an atom, right? So that you can get it. And also for those who already have knowledge about some of these things, please bear with me, right? I want all of us to be on the same page so that we can maximize um, our learning, right? I don't want a situation whereby you join the bootcamp for 3 hours or 2 hours, you don't know what is happening and all. So tonight, my emphasis is more on explaining. We'll be doing some coding though, but I want you to get the concept, right? If you're able to get the concept, it will be easier for you to like do the coding. There are some people who know how to code, but the insight aspect of it, understanding, they don't know what they are doing, right? In the field of data, you have to know what you are doing. You have to understand it in order to excel. So, in case you don't understand anything, I'm not running away. I'm here. I'll explain it to you. Okay. So, let's start with handling missing values. As I said earlier on, when you are collecting data or when you're about analyzing data, you realize that there are times, it's not all the time, right? There are times they are missing data, right? And what happens is when you use the missing data in your analysis, it's going to affect your analysis. Even some algorithms cannot make predictions so far as you have missing values, right? So one of the things you have to do is you will need to handle missing values. You will need to handle missing values. And how do you handle missing values? First of all, you have to understand. Many a times when people see a data set with missing values, they already have an idea of the techniques they will use in handling the missing values. But one thing I'll say is you have to understand what is causing the missing value. Is it as a result of data collection? Is it that some people didn't fill the form intentionally or accidentally? Is it that some people chose that the questions that were asked in the form or when the data was being collected, they didn't feel comfortable, so they don't want to share? Is it that um, the questions that they asked was not applicable to some group of people, right? Let's say someone who is 5 years old, the person is filling a form and or you are taking data from the person and you are asking the person what work does the person do. Someone who is 5 years old there, you know that the person is not working, right? So that is also a consequence of um missing value, like it's a consequence of the thing not being applicable to that person, right? So as a data analyst, data scientist, you have to understand that there are some questions that don't apply to some people, and when you are asking them, you are going to get missing values. The moment you understand where your missing values is coming from, that is when you can apply the techniques, right? So I'll emphasize on this. Don't be in a haste to don't be in a haste to use the techniques that I'll be sharing with you when you don't understand the cause of the missing values, right? You have to know whether it's data collection or um, is because optional fields or is because the questions are not applicable, right? I'm saying this because I want us to be good data scientists and good data analysts, right? I don't want us to only have the technical skill sets. All right, so what are some of the techniques we can use in handling missing values? First of all, you can remove the rows or columns with missing values, right? When you realize that some of the information provided are not accurate, you can remove them. At times, too, your data sets will determine, right? If you have a large data set and removing the missing values will not affect your data set, then you can remove them. There are times also you have to fill the missing values with either the mean, median, or mode. Normally, when you are using categorical variables, say for categorical variables, you can't find the mean of a categorical variable. Or can we find the mean of a categorical variable? Let's say gender. Is it possible to find the mean of gender? You can unmute and speak. I would like it to be interactive.
No, no.
Right. So it's not possible. Yeah. So we use the mode in that case, right? When you are filling in the missing values, we use the mode. But for numerical variables or numerical data, we use the mean or median, right? Then there is also model-based imputation, right? So this one, the model that you develop, that's what you are going to use in filling the missing values, right? So based on some of the values from your model, you use it in filling the missing values, right? I'll talk more about model in a different part, but for now, let's look at this. All right. So outliers. First of all, we have looked at missing values, what causes them and how to handle them. Now let's look at outliers. What is an outlier? An outlier simply is a value that is unusually high or low compared to most of the data. Let's say you are taking the age of a group of people, right? Let's say on this call, we are taking the age of everyone on this call. Let me look at some of your name. I know Emmanuel is here. All right, so Clement is also here. So let's say I take the age of Clement, I take the age of Emmanuel, I take the age of Celestine, I take everyone's age. Then you, probably you guys are somewhere around 20, 21. Let's say from 18 years to 25 years, right? Or let's say you guys are from 16 years to um 40 years. That's your age. But while taking the data, I realized that someone is 2 years and the person is on this call. Like the age of the person as the data was collected was 2 years. You know that if you are 2 years, this is not what you'll be thinking about. 2 years, you are thinking about um, what you'll be eating, like what your parents will be giving to you and all that. Or you are there crawling, you are playing with other children. Or let's say someone is 100 years and the person is on this call. Someone who is 100 years, not learning about outliers, right? I mean, the person will not be thinking about learning data science and all. Or it's rarely possible for such a thing to happen. So we call those things outliers. They are unusually different from the manual data you have or the actual data set you have. They are unusually different. All right. So what can cause this or what can cause us to have outliers? One of the things that causes us to have outliers is data entry errors. Let's say someone wanted to enter 20 years when the data was being collected. Or let's say, yeah, the person wanted to enter 20 and the person entered 2. So that's the reason why we are having 2 as part of the data. So it's a mistake. Or maybe someone wanted to enter 15 and the person accidentally added a 0 to it. So 150, right? So it's a reason why we have outliers. Right? There are times also it's actually a real life scenario. For all you know, there is someone who is living on this earth who thinks, oh, in my youthful days, I didn't do much, right? Or I wasn't exposed to technology. So when the person saw this boot camp, right, the Ugass Data Science Club boot camp, the person decided that although I am very, very, very old, I'll participate in this boot camp, right? It can be like in real life, we say it's hardly likely for it to occur, but someone can do that. I don't know if you get what I'm saying. If you get what I'm saying, can you give a thumbs up? Uh, can you give it? Okay, thumbs up. Okay, I'm seeing 2, 3. Okay, hey, Celestina, I hope you guys are here. All right, let's continue with my slides. Yeah, so that's a result of or what causes us to have outliers. Now, how do we detect outliers? We detect outliers using plots. Um, One of the plots is box plot. I'm sure in your, I don't know if all of you are stat students, right? But if you are stat students or you did stat 111, you realize there is something called a box plot. It shows you the first quartile, second quartile, third quartile, median, mean, and maximum value, right? Yeah. We use that box plot to tell whether we have an outlier or not. We also use interquartile range, right? So there's a formula for it, and as we progress, we'll look at that also. Yeah, we also use z-score, and z-score basically measures how far a value is from the average. Okay, so how do we handle outliers? Right. So just as I said for missing values, you have to understand what is causing the missing values. Don't just apply any of the techniques, right? You have to actually understand what is causing the missing value. Same with the outliers. You have to understand what is causing the outlier before you decide on how you handle it, right? I have a dicey question for you, right? I'll ask you a question, but first of all, I will explain how we can handle outliers. Then after I pose my question to you. All right. So one of the ways is we either remove the value from the data, right? You remove the value, or let's say you divide your data sets to reach a certain point. You don't include the outliers. So let's say you have 20 data sets or data points, right? You intentionally exclude the first two and the last two from the data set. That's one way you can handle outliers, and that's using robust statistics. This we term it as trimmed mean, right? So you exclude some of the data points, then you calculate the mean, and with that one, you are able to handle those outliers. And also you can cap the extreme values, right? So if you realize that maybe 100 is an outlier, you look for a certain percentage in the data set. You look at the data set, a certain value, then you replace all the outliers with that specific value, right? That's what we term as cap extreme values. Then you can also apply a transformation to the data, either log or square root transformation. And this will also reduce the extreme values. All right. So before we proceed to the next thing, I would like to ask, assuming you own a shop, right? This one I would like to come here so that I can see those who try to answer. Yeah, so assuming you own a shop, right, and your shop makes a certain amount of sales every now and then, and there is an average amount of money like you make based on the sales that you have been running every now and then. Then one day a billionaire steps into your shop and he buys from your shop, right? How will you handle this outlier? Please, is the question clear? Hello, hello, hello.
Uh,
Hey,
Hello.
yeah,
Hello.
yeah. Please, is my question clear? If
Yeah,
if it's not
yes,
clear,
yes.
it's clear. Okay, Clement, you
Not
can
really.
proceed. Oh, okay, I'll take it again. Don't worry. Clement,
Yes.
Clement, I see that your
Yes.
hand is raised. Yeah, you
Okay.
can ask your question or proceed.
Okay. Since the sales is out of the extraordinary or it's not the normal average, so you include it in your annual. Maybe if you are doing your annual sales, you include that one because it's an outlier.
Okay. All right. So, Emmanuel, the question I was asking was, you have a shop. Your shop generates an income, an average income every month, right? And one day, a billionaire walks into your shop and the billionaire buys a lot of things, or even if he buys something which is less expensive, he buys many of them, right? So as a result, your daily sales or your monthly sales has increased tremendously, right? So that's an outlier. It's different from what you make on an average, right? So the question I was asking is, will you consider leaving the billionaire to be part of your data set and make analysis with it, or you remove the billionaire's data because it's an outlier? Please, is it clear now? Okay, Edu Jemfi.
You limit, you use the cap extreme value. So the amount that he paid, you reduce it to a reasonable amount so that it matches with the average sales that you make.
Okay, all right, that's fine. Franklin, your hand is raised. You can proceed.
So please, can you take the methods of handling the outliers after again?
Okay, all right. So one way of handling outliers is by removing them, right? Another way is by capping them. And when I say cap, I mean you look for, let's say, from your data sets, from 10% to or 90% of your data sets, you look at what the 90th percentile value is, right? Then you replace any value above that with the 90th percent value. Let me take that again. Let's say I've mentioned one, you remove the outliers. Two, you cap them. So let's say you take a certain value and you set that value as the benchmark. If any value that comes in exceeds that value, what you do is you change the data point with the benchmark that you have. So let's say you have set your benchmark to be 1,000. If you receive a data set which is 2,000 or a data point which is 2,000, you change the 2,000 to 1,000, right? Yeah. Okay, Franklin, your hand is raised. You can go ahead.
The one
You are
who asked
sorted
the
out.
question. Yeah.
Come again.
No, you've answered the question.
Oh, okay. All right. So I'll proceed to um oh I'll proceed to answer. Okay, Clement, you can go ahead before I answer the question I asked.
Can you please come again?
All right. Okay, so you have a shop, right? And the shop makes a certain amount of money every month. But there was a month that a billionaire came into your shop. And because the billionaire came into your shop, he bought a lot of things, or the things he bought cost much. So this time, if your average sales you are making is 2,000 cedis, because that billionaire walked in and he bought a lot of things, your average sale now becomes 100,000, right? So what will you do? When you are doing your monthly report or whatever, would you include the billionaire in it or his purchases in it, or you exclude it because it's an outlier? Is it clear now? Yeah, so what will you do?
So you exclude it because it's an outlier.
All right, so let me answer the question. Okay. Both of you or everyone who contributed said something which is one way or the other true. because the person is a billionaire and the things he bought like added to increasing the average you have, is it gives a different picture of the sales you make, right? But one thing I'll say is you will not have to remove it as an outlier. You still have to leave it. I'm sure someone is asking why. Why? Because for all you know, the billionaire you had has become your new customer. So if you are to exclude it, you are not going to get a true reflection of your business. What if the billionaire comes and buy again? Will you remove it because it's far different from what everyone is buying? So you realize that when you remove the billionaire, you wonder, hey, where is all this money coming from? And you might not be able to account for it because the money that the company is getting, let's say, is 2 billion. But when you were doing your analysis, you removed 1 billion from it. And the company has 2 billion, but your data is saying that they have 1 billion. So what that will happen is some people will be crafty in this and they will capitalize on that. That's where some people will start stealing money, right? Because no one can catch them. They have partnered with the data analyst, and the data analyst is helping them, you know, um, get some money. One thing you would do or you should do is you have to include the outlier, but at the same time, note or state in your report that the average mean, let's say, is 7,000, but due to a certain reason, the average rose to 1 million. So this time you let them know that there was something that happened at this point. So maybe that's when they'll tell you to further investigate. Maybe someone mistakenly sent money or a transaction, or even the billionaire, you know, because they have money in abundance, maybe the person was sending 1,000, then he clicked like more zeros. That's why it happened that way. So you do further investigation, right? One thing I'll also add up to what I've said is anytime you see an outlier, find out where it's coming from. You only remove outliers um when it is a mistake. Let's say someone was supposed to enter 20 and the person entered 2. This one you can't add it to your data set. If it's a mistake, you have to remove it or change the value. Change the value to 20, or like you can, based on the data set you have, you can fill it. You can fill it. Please, do we understand? Please, do we understand? Hello. Oh,
Yes.
okay. Right. So I want us to get the technical, sorry, I want us to get the concept, right? The understanding before we zoom into the code. I don't want a situation whereby you are coding, but you'll be making wrong decisions. So just imagine, imagine you were working in a company and I taught you the skill set, like how to remove the outlier using the libraries and all, without giving you like this kind of scenario. Like someone will be losing money by now. And I'm just hoping you apply the knowledge in the right way. Okay, encoding categorical variables. Now I'll explain what a model is, then I proceed with what encoding entails. A model simply makes prediction based on an input, right? For any machine learning algorithm, or when I say an algorithm, it's just a step-by-step process, something someone takes to complete an action, right? And normally the computer takes a certain number of steps before it can complete an action. That's why I call it algorithm. So when we talk about machine learning algorithms, we are talking about a certain sequence of steps that the computer takes to perform machine learning tasks, right? There are different kinds of algorithms and all. What is a model? A model basically represents an equation, right? An equation that the machine, when I say machine, I mean the computer, right? The laptop or the programming language uses to make predictions. As simple as that. So anytime you have a model, you give it an input, it learns from the data, it learns patterns from the data, then it will give you an output. Please, do we understand that? If you understand that, you can give me a thumbs up.
Please come again.
All right. So I was saying, when it comes to a model, or what a model is just an equation. Okay, theoretically, it's just an equation that accepts, or let's say it's just a function, right, that accepts inputs, learns from the input, and produces an output, right? So let me give you um, a scenario. Let's say when you were younger, especially the ladies, you guys played Ampi, right? They have, is it Okonton and Oswete? When one leg match, this person has won. When the there is variation in the legs, another group has won, right? So you realize that there are some people, they are so good that they can win like 5 people on the bounce. They are able to learn the patterns from other people. They know that when they use this leg, the other person will give the other leg, right? So there are people who know how to do all those things, and they are able to learn from it and make predictions. That's the same way a machine learning model, you give it a data, right? And once it receives the data, it learns from the data, just like the way you learn how to play MP, you learn the patterns of the people you are playing with, right? So the model also learns that pattern and it produces an output. Is it clear? Or man can ye? Hello, Celestine.
Yes, it is. Thank you.
Yeah. So that's what a model is basically, right? But models don't deal with texts. Models actually work with numbers. So anytime you are to use, let's say, a text in the model, in machine learning model, in building the model, it will give you an error, right? It will give you an error. And one thing, this just by the way, for you to have an added knowledge, even with ChatGPT, when you give it the text, it converts the text into a numerical form or in a form that it can understand. When you take even pictures, right? Maybe you want to detect disease in plants or something, the model will have to convert the image into like numbers before it can make prediction. So any model that you'll be working with, machine learning model, it doesn't work with text, right? Even if you have a machine learning algorithm that allows text, it has an inbuilt function that will deal with the textual data, right? So what do we do then if you have a model that does not only work with numbers, that only works with numbers, I mean, is that the end for you? No. You can convert the numbers in a form that the model will understand. And this is what we term as encoding. We call it encoding categorical variables, right? So as you see here, encoding converts categories into a numerical format models can understand, right? And there are several types of encodings. We have ordinal encoding, we have one-hot encoding, we have label encoding, we have target encoding, we have cyclical encoding, we have several of them. But for our level, we'll start with ordinal encoding and one-hot encoding. As we progress, you will get to know the other types of encoding. All right, so I'll start with ordinal encoding. You use ordinal encoding when there's a natural order. Let's say big, bigger, biggest, right? If you have a data set which has that form, or let's say the size of a house, maybe small, large, extra large, or the size of a shirt, small, extra large, extra large. That follows a certain order, right? So what you do is you use ordinal encoding for it. Ordinal, ordinal, ordinal. So it follows a certain order. But in case there is no order, what you use is one-hot encoding. And examples for things like that is gender, male or female. There is no order. It's not like someone will say male is greater than female or female is greater than male. Such a thing does not exist, right? So that one, we use one-hot encoding. All right. So with the one-hot encoding, what you do is, let's say if you have team A, you are seeing the data points are A, B, C, and all that. What you do now is anywhere you see A, if you want to write A, anywhere you see A, you put 1 there. Then the other ones will be 0, 0, 0. When you see A here, you see 1, then 0, 0, 0. B, you only fill the part that you want. B will be 1, then everywhere will be 0. If you want C, everywhere will be 0, then the C column will be 1. Don't worry about this. The machine will actually handle this for you, right? But I just want you to appreciate the theoretical concepts, right? That's why I'm taking my time to explain some of these things. Under normal circumstance, people will just, skip and go to the coding aspect. All right. Wow. Feature scaling. Now, when you are dealing with models, right? There are times there are difference in numbers. Let's say you have a column for income, right? And income people earn from, let's say, 800 cedis going. So you have a column that's 800 cedis. Like it is 800 in value, 800 and plus. You can also have a column like age. That is, let's say, from 20 to 80, right? And someone's salary can be somewhere around 8,000 cedis and all that. So when you have something like this, it's difficult for the machine learning model to see, or it's difficult for some algorithms to see the pattern, right? Because there is vast difference in the columns, let's say the income and the age. It's not able to learn well, it's not able to see the patterns, right? And it leads to it performing poorly. Right, so what we do is we scale the features. When we say we scale the features, we convert it into a form that it will be easy for the machine to learn, right? And there are several methods we use. We use standardization, right? The Z-score, such that the data center is around 0 and the standard deviation is around 1. We use min-max scaling. That one too is usually from 0 to 1. All right. Okay, we are getting somewhere. Okay, so we have gotten to EDA, but at this point in time, I would like to ask, does anyone have a question for me?
Sir, please, I didn't get the feature scaling.
All right. So with regards to the feature scaling, we scale features that have large differences in number. Let's say you have a column for income, which is 1,000, like it has the value 1,000, 2,000, 20,000, and 50,000, right? Then you have a column like age, which is, let's say, ranging from 20 to 80. When you have such columns, you can realize that numerically they are different. If you look at 100,000 or 20,000 and you compare it with 25, you realize that numerically there's a difference within it. And most machine learning models, right, or some machine learning models use something like distance in calculating, in doing things that will help the model learn faster, or that will help the model learn from your data, right? So when you have these two different columns, it will be very difficult for the machine to learn well, because if the machine, let's say, subtract the two, right, is doing the internal work, it's going to get a large number. Or if you compare it in terms of distance, right, it's going to get a large number and it will not learn from the data well. So we scale the numeric columns, right? We'll scale age, we'll scale income, so that both of them will be within a range that the machine can understand. So age will no longer be one, it will no longer be 12 years old, it can be 0.5. It has been scaled, a transformation has been done to it. Income will no longer be 20,000, it will be maybe 0.2. It has been scaled. Like, are we on the same page? Is it clear now?
So, like when you scale, like you scale them, it helps the machine use them better.
Yeah, to learn. Or it helps some algorithms or some models to use them better.
But why can't it use the ones with big disparities?
Yeah, the reason is because some machine learning models are based on distance. When you look at a regression model like this, it will plot the point, right? Or the point, then it has something it calls line of best fit, right? It uses that to see how close the points are, to the line of best fit. And if you are anytime you are dealing with distance learning models, you are dealing with algorithms that uses distance. This will be a challenge because the distance will not be reflected well.
Okay, I think I get it.
All right, great. All right, so we can proceed. So EDA is simply exploratory data analysis. And this is one thing you have to know very well as a data analyst and a data scientist, right? Why should you do EDA or exploratory data analysis? First of all, you want to understand the structure and patterns in the data. You want to see what feature contributes to the data sets, or at times you even want to know the key performing indicators, right? You might want to know the number of meals in your classroom or in your lecture hall. You might want to know the average income of your customers so that you are able to like plan well. Right? That's why we do EDA. At times, so you also like to detect anomalies. When we say anomalies, something that is abnormal. And as I made mention earlier on, outliers, missing values, errors, and all, you would like to determine them before you do modeling. Also, you like to identify the relationship between variables. You want to ask yourself, do two variables correlate? Um, yeah, do they correlate? Is there a relationship between the variables? So because of some of these reasons, we do EDA. All right. Okay, so typical steps of EDA. So EDA, we do summary statistics. You look at the mean, median, min, max, standard deviation, and all. It will just give you a quick overview of the data, right? You look at distribution plots, histogram, box plot, density plot, to see the distribution of the data, right? There are some the moment you see a histogram, you can tell that this is rightly skewed, right? When I say rightly skewed, some of you might not understand, but as time goes on, we'll understand some of these things, right? I don't want to speak about, to bombard you with a lot of things. So as time goes on, we'll get to know about this. Then after you look at the distribution, you also look at correlation. How are they correlating? Then you also examine how the features relate with the target variable, right? In machine learning, you are more often than not making a prediction, right? You want to predict maybe whether someone would default a loan or not. You want to predict the price of cocoa. You want to predict whether an image has a disease or not. So in machine learning, you are doing prediction, right? So what you are looking out for is the target variable, and the features that you will use in making the prediction is the um what we call features here. We call features or independent variables, right? So maybe I want to determine if someone is a bad student, right? So the target variable will be yes or no. Yes, he's a bad student. No, he's not a bad student. Or yeah, so that's the case. And the features will be what will I use in determining whether the person is a bad student or not? The person disrespects his lectures, right? So it can be a feature. Disrespect the lecturer, yes or no. Does assignments, yes or no. Attends class, yes or no. Um, Pays attention in class, yes or no. Like I'll use different metrics to do that, right? And those metrics are the independent features. All right. So this is just a heat map showing the correlation between two variables, right? Um, Correlation ranges from -1 to 1. The more your correlation is close to +1, we have a term we call it positive correlation. If it is close to -1, it's negative correlation. And if it is 0, it is there is no relationship, so it doesn't correlate. Um, Assuming it is 0.5, we call it moderate correlation, right? Yeah, then 0.7 thereabout is increasing. The correlation is increasing. And also, you have to know that correlation doesn't imply causation, right? The fact that two things correlate doesn't mean one causes the other. They can be correlating, all right, but one does not cause the other. All right. So at this point, I would like to ask any questions. We'll be diving into the coding aspects soon. Okay, question, Isaac.
Hello, please. I think I joined late, so I didn't get what you guys did. So can you please do recap of what you did?
All right. So if I'm to do a recap right now, please be told it's going to take a long time, right? Like it's going to take like some part of our time, and we are pressed
Okay.
beyond time. So what I'll do is, as I'm explaining the code or as I'm running you through the code, I'll be explaining I'll be explaining some of the things we we did. Okay, is that fine? And this
Okay.
section is being
Okay.
recorded, so you'll be able to watch that also. Yeah, so
Okay.
Celestina,
So that are we going to have this session like continuously?
yeah, next week we'll have another session, right? But I'm looking, if I'm not able to cover everything tonight, I'll arrange for us to meet again within the week before Sunday so that we can learn. Like we can look at the coding aspect because I just finished explaining the theoretical aspects. Right. I want you to be
Oh,
grounded in theory, then from there we can take the coding aspects. right? So
Okay.
we'll be moving on to the coding aspects.
Okay.
Yeah.
Thank you.
Celestina, you are welcome. Celestina, is your question answered?
Yeah.
Oh, okay. Thank God. All right. So what's next? Let me see. We are done. So time to dive into the coding. Right. So I'll be using what I call an ID, or yeah, I will not be using Visual Studio Code. I'll be using Jupyter Notebook. All right. I'll be using Jupyter Notebook. And all right. Yeah. So first of all, you need Anaconda. But how many of you have Anaconda? Hello. How many of you have Anaconda? Hello. Oh, if you have Anaconda, you can give a thumbs up. If you don't have, you can also let me know.
I don't know.
At least we don't have anaconda.
Okay. All right. Do you know, I was just saying, somehow, the moment I said, do you have Anaconda, someone will be wondering, hey, is he talking about a snake or like, what does he mean, Anaconda? Don't worry. Anaconda is a software that data scientists use in their line of work. It has several applications or packages. Okay, we can use. Isaac,
Please, I want to ask that, like, with the anaconda, no, can we
download.
use the online one, or we can download it so that we can use it on our local machine?
You can download it and use it on your local machine. Yeah, so you just have to download it. Mm,
Oh,
so
okay.
the Anaconda download and run and then download an ish. Pretend you didn't hear. Yeah, download Anaconda. Yeah. All right. So hopefully within the week I'll take us through. I'll make time, right? At times my schedule is very tight, but it's not at times. My schedule is very tight, but I'll make time so that we can meet, right? So that those who aren't able to take those who don't have an account that Jupyter Notebook, I'll just take you through the process so that you can also do it, right? So first of all, if you have Anaconda already installed in your machine, you can just come to. For me, I already have it installed, right? And I'm already using it. So you can see the base here, right? So you just type Jupyter Notebook. The moment you install Jupyter Notebook, you just type it. Oh, I didn't spell it well. Jupyter Notebook. Yeah, then it will load, right? The moment it loads, I have a folder where I have the projects in, right? Wherever your folder is, if it's on desktop or downloads, I think mine is in downloads. Yeah, downloads. Then you come to that place, China more customer data, right? Then here's the notebook. I intentionally placed the CSV file and the notebook in the same directory or in the same location so that things will be easier. All right. So um I'll take this from the basics, right? I'll take this from the basics. Spare me 5 minutes for me to explain what like the libraries are. So as data analysts, we have tools we use in our line of work, right? Just like Masons have tools they use in their work. As data analysts, the tools we use help us to clean the data. It helps us visualize the data. It helps us in building a model or making prediction, right? Just like when you are building a house, you have to lay the foundation. There are certain things you use at the foundation, right? You don't use the paint at the foundation, true or false? Am I right on that? When you are
Yeah, you
building,
are right.
yeah, you don't use paint at the foundation. Same with data, like data cleaning, data analysis workflow. When I say workflow, I mean the structure or how we work. We start from somewhere and we end at somewhere. So there are tools we use in our analysis journey, right? And the tools we use, Python is a programming language we use, right? And Python has a lot of packages. We call them libraries, or let's say Python has a lot of libraries that will help us make our job easy, right? So we have a library called Pandas, we have a library called NumPy, we have a library called Matplotlib, Seaborn, sklearn, and all that. Those are the things that we use in our line of work. Now, what you see here as PD, NP, PLT, SNS, you'll be wondering, why import as PD, as NP, and all that? We want to use these tools. Anytime we want to use the tools, we have to call them, right? Or you have to take the tool before you can use it. You don't use a hammer with your mouth, true or false. You have to walk and take the hammer. So with these libraries, we have to call them, right? But if we are calling them with like pandas, it's going to be long. Like anytime we want to use it, we'll type pandas, whatever, whatever. I mean, that's too long a process. So what we do is we give it a nickname, right? So rather than say pandas, we call it PD. Rather than saying NumPy, we call it NP. Rather than saying matplotlib.pyplot, we call it PLT, right? So what we do here is we import all the libraries that we'll be using. Anytime you'll be doing a data analysis work or data science work, you import your libraries. You import your libraries. You import your libraries. Importing your libraries, you are just bringing your tools into a room, right? Then anytime you need them, you go for them. You call them using the various nicknames they have. So with pandas, the nickname is PD. With NumPy, the nickname is NP. With Matplotlib, the nickname is PLT. But note, these various tools, they have other sub tools within them, right? So there are times we have to go to a specific place, or we have to go to the specific package, then we pick the tool from that package, right? So sklearn is also a library in Python that helps data scientists. It's normally used for machine learning tasks, right? But it has several packages, right? Use we don't want to use the whole package almost all the time. So there are times we only import specific parts of that package or library. So rather than say import, I'm coming, rather than say import sklearn dot preprocessing dot one hot encoder, we say from sklearn pre-processing. So from sklearn, the pre-processing side of sklearn, give me one hot encoder. From sklearn pre-processing, give me standard scalar. From sklearn pre-processing, give me min-max scalar. From sklearn pre-processing, give me ordinal encoder. That's what it is basically, right? And please, are we clear with that? Please, is it clear, like the libraries, or you already know it? If you already know it, I can just skip through. Hello. Oh, only one person is giving feedback.
Yeah.
You already know the libraries, like what it means, their representation and all. Oh, okay, that's fine. Okay. So let's move on then. So let's import the libraries and we use command A. Sorry, I'm using a MacBook, that's why. I'm sure in Windows it's Control plus Enter, right? So you run Control plus Enter, then it will run the cell, right? Or I use Alt plus Enter. It will run the cell and leave a space. Now, the data set that I'll be using, I have to load it into a place called a data frame so that I can use it, right? So since it's a Excel file, sorry, it's a CSV file, I'll just do pd.read CSV, right? Then I indicate where the folder is. I indicate the name of the file, right? So df equals pd.read CSV. Then you add the file name. What df.head will do is it will give you the first 5 rows, right? So first of all, the data set is loaded into a data frame, right? After it's loaded into a data frame, right now you can call the data frame. Okay, df is simply a variable, right? A variable is more like a storehouse where you keep something. So what we have done here is we are keeping our data set in df. Anytime we need our data set or anything related to the data set, we go to df and we add an operation to it. So here when you press df.head, you tell it that df, I want to see only the first 5. In case you want to see the last 5, you say df.tail, right? It will give you the last 5. Or you can specify maybe last 10. It will give it to you, right? Um, then you run df.shape. Df.shape will give you the number of rows and columns, right? So there are 20,600 rows and there are 20 columns. The hash sign you see is comment. Anytime I write something and there is a hash sign, when I run it, I will not get an error because it's a comment, right? It helps you understand, or it helps other people also understand your code, right? So when I run the code, only df.shape runs. But so far, do you understand whatever we are doing? Hello.
Hi.
Yeah, Franklin, your hands are up.
Sir, please, where did you store the China More CSV file?
Okay, so the China More CSV file is in a folder on my laptop in the downloads, right? When I come here, you see it. China More, right? That is here. I stored it here. All right. So just because of the question you asked, let me say this so that in case you go to normally, normally what we do is um you do pd.read underscore CSV, right? Then the file path, right? Wherever the file is. So the file path. So the file path simply gives you the location of the file, right? You do that, then you run the code. But I know since I am viewing it from a beginner like perspective or beginner approach. So I don't want to stress you guys. I just place the file in the folder. I place the CSV file in a new folder so that I don't have to indicate a file path. If not, I'll have to indicate the file path. and the file part will be where it is. So users, then my username, right? The folder is in, sorry, users, username, downloads, right? Then where else? If I'm not in the folder, then maybe China folder before I indicate the file, right? But someone will say it's too much of a work or a DOS to do. So I just place the CSV file in the same folder I have the notebook so that I can just run it. I hope we are clear on that. Is that fine?
So the notebook and the CSV file are all in the same folder. So that's why you're able to call it with a function.
Yeah. That's why I was able to call it without specifying the file part.
Yeah,
Yeah.
that's what I was
So,
asking.
oh, okay, yeah. Yeah, that's fine. All right. So from there, we move on to the shape. We look at the shape of the data sets. You have to know the number of rows and number of columns, right? So the number of rows is someone talking or asking a question?
Yes. Please, how can we
Okay.
get the data so we can maybe
Oh, the
try
data
pull out?
sets. I'll send it after the class. Right. I'll send it to
Oh,
you.
okay.
Yeah. Initially, I was trying to get a data set from Kaggle. Right. Kaggle is open source. It has a lot of data sets, but some of the data sets were already clean. When I say clean, they had no missing values, no duplicates. There are some, they didn't have columns that we can perform feature scaling and other things on. So I intentionally let ChatGPT generate this data set, right? So that it can give us duplicates, it can give us missing values, it can give us different problems so that we can navigate our way through, right? That's that's the reason why I made Chat give us this. But as time goes on, we'll introduce you guys to some of these things, like getting data sets from other sources. Isaac, your hand is up.
Please, I wanted to ask that you said Panda is a package, but
Yeah, a library.
what is the use of that particular package?
Okay. Sorry, I meant a library rather. It's a library rather than a package, right? So
Okay, okay, like
yeah, a package has a lot of libraries in it, right? Yeah. Okay. So
yes.
the use of pandas is for data cleaning and data manipulation. So we use pandas to clean our data. Oh, I realized I didn't explain it. Yeah, so we use pandas to clean our data. We use pandas to detect outliers. We use it to manipulate our data. Let's say a column has not been named well. You can use pandas to rename the column. You can use pandas to perform exploratory data analysis and what have you. You will get, like, as I'm doing it, I'll be explaining some of these things. I
Okay,
hope
okay.
we are good
Thank
to go. So we can continue.
Yes, yes, please.
All right. So aside that, what else? Okay, so df.info. One thing I'll say is as you practice, you have these things at the back of your mind. Maybe for a first time, it might be a bit difficult for you to remember some of these formulas or some of these like functions and all, but as you practice, you'll be able to do them with ease. So df.info, it will give you an information about the columns, the number of not null values, and the data type, right? So when I say not null values, I mean values that are not missing, right? So here you can see the column names, transaction ID, customer ID, the gender of the customer, the age, income level, marital status, and different kinds of things. Um, D type, just the data type, right? So it stored the data type as integer. That's for customer ID, objects, integer, and or what have you. Normally for things like transaction ID, we don't perform calculations on it, right? Because we don't perform calculations on it, what we do is we change the data type, right? So what I'll be doing right now is to change the data type. We change the data type into a form that is acceptable. All right. So if I type df.info, the data type should change. So you realize that right now it is object, right? So anytime you want to call a column, you enter the name of the data frame df, then you put the column in square brackets. So anytime you want to use a column, right, or you want to call it, so that's what I just did. Then I said as type, I want it as a string, as an object. So you just have to indicate it as str. If I don't bring this, I'm going to get an error, right? Because it is not defined, right? So please be on the lookout. All right. So we have done that. What else? All right. So we can also do the same for customer ID, right? So df customer ID. We change the data type to object because we are not going to perform any numerical computation on it, right? The thing is, after we change it, we assign it back to the variable. We assign it back to the column as a variable. Okay. Yeah. All right. So, okay. One of the main things I'd like us to look at in the data cleaning process, right? When you start cleaning your data, you have to check for duplicates, right? So df.duplicated.sum. So this one will check if there are duplicates in your data set. So let's run it and see. It gave us 600, right? It gave us 600. So what we'll have to do is we'll have to drop the duplicate, right? So you can use df.drop duplicates, then you assign it back to the data frame. You can either do this or do it this way, right? df.drop duplicates. In place equals true. Then in place, what it's doing is telling you is that you are replacing the old data frame with a new data frame, right? Here, rather than replacing the old data frame, I just assigned it, right? So you can do any of the two, right? So df.drop duplicates. After you are done doing that, you check if there are duplicates again. So there are no duplicates. But so far, do you understand what we have done? Like, is it a bit difficult understanding? I'd like to hear from you.
Yes.
It's a bit difficult. I think Isaac said you came late,
Yes, I came in late.
and so maybe maybe you get to understand when you watch the video. But Dennis, Celestine, Franklin. Okay, Franklin, go ahead.
I think we really
So
appreciate
please, earlier you said the
the
DF is a variable. So does it
Yeah,
mean we can change the name to anything we want?
yeah,
Okay, so
yeah.
the data frame, what is the data? Is it the entire data set or is like a portion of it that you're working on?
So the data frame is the entire data set.
Ah, okay.
Yeah,
So
it's
the
the entire,
whole thing.
yeah, the whole data set. But
Okay.
mind you, there are some people who can only take a part of the data set, right? Someone can only like take a portion of the data set. But even with that, you first of all have to you have to have the whole data set before you can decide to take only a part of the data set. I hope you get it.
Yeah.
Yeah, but Celestine, how is it? What we have done so far? Do you understand?
but then
Clement.
okay,
Okay,
if I
Celestine, go
was
ahead. Please come
yes, but
again.
then if I was practiced, I've not downloaded them, but I don't have the
Oh,
data.
okay,
So
but
maybe
if you
then
okay,
that and I practice it, I may be very conversant with it. Yeah, thank you.
okay. All right. So let's continue. All right. So what else? We have dropped the duplicate, right? So we can continue with whatever we are doing. Um, Normally there are some columns that will be irrelevant to your analysis, right? If you are performing data analysis, it's not every column that might be beneficial, right? So here in this case, the transaction ID, we are not really interested in the transaction ID, right? Um, okay, the transaction ID can be beneficial in some regards, right? It will depend on what you are doing. The analysis that we are doing tonight, my focus is not related to the transactions or the transaction ID, but you can include it, right? My analysis is not based on that. So you can decide to drop them, right? When you want to drop a column, you use df.drop, then you specify columns equals. So df.drop, the columns you want to drop is equal to, because there are multiple columns, that's why we are using the square bracket, right? Assuming it's only one column that you want to drop, that one you not even indicate the columns, you just take this out and you specify the column name in quotes. You will not drop it. I'll not drop it. df.describe, it gives you summary statistics of the numeric values. Mind you, when I was doing the reference, when I was doing the slides, I made mention that we do EDA to have what summary statistics, right? It gives us the mean, median, min, max, standard deviation, and all. So here, df.describe will give you a summary of the numeric values, right? So you realize that age, the mean is here, 34. The standard deviation is 11. Negative 16, meaning someone made a mistake. We can fish out that age and make changes to it. 25% the first quartile, second quartile, third quartile. Yeah, same for the frequency count. So here you can look at your data so easily and you know the average for the average quantity that is going in is coming out, the total amount you are making on an average, right? You can know the discounts that you are being given. You can know the final amount in CDs. There are several things you can get to know from this, right? You realize that this is only for numeric columns, right? In case you want it in a table formula, you just add a T to it. Then This one presents it in a nice and neat way. Okay. And in case you want to know for categorical variables, you use objects. Include equals object, right? Include equals object. And this one, categorical variables, we can't find the mean, the standard deviation of it. So the structure will be different, right? So here you get the count, the unique. Unique simply means how many different values are there, right? So when you look at gender, how many different kinds of gender do we have? Male and female. That's why it's two. Income level, how many different income levels do we have? Middle, low, high. Yeah. Then the top is let me see, top 3114. So okay, wait, I'm coming. I'm trying to find out something. Yeah, top is what occurs the most, right? So out of it, this transaction ID appeared several times. Female appeared several times also. Then the frequency gives you the number of times it's happened, right? So females appeared 9,885. Yeah, right. So let's check for missing values. So a quick recap. What we have done so far, we have checked for duplicates. Any data cleaning process you are doing, ensure to check for duplicates. Check for summary statistics, right? I even made a mistake. I was supposed to do the summary statistics later, right? Because there might be some missing values and all those things, or there might be outliers and all. So if we perform those operations, then we can do the summary statistics. All the same, we are good to go. So in case you want to check for missing values, you use a function is null dot sum. The reason why we are adding dot sum is dot sum gives us a number, right? If you don't add the dot sum, what will happen is you have true, 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 false, true, false, true, false, right? So df dot is now, oh, it's giving us false, 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 false. So we sum it, we tell us to give us the sum of the missing values. Then tells us, okay, so transaction ID has 0 missing values. Customer ID has 0 missing values. Gender has 1,000 missing values. Age 0. Income has 1,000 missing values. Marital status 0, 0, 0, 0, 0, 0, 0. Then final amount has 0 missing values. I think it's self-explanatory. True or false? You can just tell the missing values from it.
But I don't understand.
All right.
What's the meaning of the zeros and the thousands? Doesn't mean that it is thousand. There are thousands of data that are missing. Or
Yes. Yes. But this time it means that for that particular column, right? If you look at that particular column, 1,000 of the values are missing, or there is no value for it.
oh, okay.
So let me see. What was I looking at? Okay, let me take gender. Right, let me take gender. So you realize that gender, nothing is here. It's a missing value. The person didn't indicate whether it's a male or female, right? So there are thousands of this, or there is exactly 1,000 of this missing value. This is not the only missing value. When you scroll downwards, you should see another one. You should see another one. All of this about 1,000 times. That's what it means. I hope you're okay now.
Yes, please.
Okay, so in case you want to see the percentage of missing values, you look at the sum, right? The sum over the total number of missing values, then times 100. This is mathematics, right? So means len is used to give you the total length of something, right? If you write len of df, it will give you the total number of data points. So we run this code and it gives us the percentage, right? So there are 5%, 5% missing values, 5%, 5%, 5%. In case you want to, you remember I made mention that with regards to missing values, you can remove them, right? You can drop them, right? So one thing you can do is, if you want to drop any missing values, you just write drop ne, then it will drop the missing values. Drop ne, it will draw the missing values. Also, I didn't include this in the notes, but if you want to check for missing values, you can also use df.isNA.sum. It's the same thing, right? It's the same thing. There's no difference. That has also given us the missing values. Right now, I just perform an operation, right? I just drop the missing values. That's why it's giving us 0, right? I just dropped the missing values. That's why it's giving us 0. So far, are we okay up to this point? Hello. Hello. Okay, Ferdinand.
Yes.
Okay, Ferdinand, you raised your hand.
Please, so the missing values that we have dropped, won't it affect our calculation going further?
Okay, that's a good one. The purpose of us dropping the missing values is not specifically for the analysis, right? It's just me showing you how to do it. So you realize that even here, num calls equals df dot select d times blah blah blah. This is also a way of filling in missing values. You use the fill ne, right, to fill the missing values. So I'm just trying to show us how to do it. It's just not directly for the analysis. But one thing I forgot to even say, I think I said it, but I didn't say it well, or I didn't amplify it. When it comes to missing values, right? When you are having, after you have investigated the reason why the missing values are occurring, whether it's a mistake or not, this one, you know that it's not an actual data set. It was generated by ChatGPT, right? It's just a case study. It was generated by ChatGPT. So I can't say it's a mistake by someone. I intentionally told him to include all these things, right? So yeah, with something like that, you can drop the missing values. In case the missing values is like 5% of your data, that's less. You can drop it. There are times, okay, I thank God for remembering this. One thing about data analysis, data science, you have to engage your stakeholders, right? A stakeholder is basically someone who is involved in the work you are doing, right? Or the person has an interest in whatever you are doing. He has a stake in it, right? So anytime you are doing a data analysis, it's either someone gave you the work, even if it's your own job, you want to do something, right? So you have to ask the people who have given you the data sets or the assignment that say, I realize that there are 1,000 missing values in the data sets. What do you think caused us having these missing values? Is it a mistake? Is it intentional? Then they will tell you, oh, it's a mistake. You can delete them. At times they will tell you, oh, they don't really know. So do what is best. That's when you look at every possibility and you just go ahead with whatever decision you take, right? Yeah, so that's that about dealing with missing values. So add this also, stakeholder engagement. As a data analyst, data scientist, you'll be engaging stakeholders. You are working for people, right? So anything you encounter in your data analysis process, even if it's duplicates, like make sure that they are aware, right? You don't just perform the analysis and you provide insights. At every stage, they must be involved. If you are doing the data cleaning, the data exploration, you share it with them so that if there is any change they want, they can add it. This is actually not part of what I'm supposed to teach today, but I believe as you are learning, we are preparing you for the professional world, right? We are not just teaching you something for you to practice. We are preparing you so that when you are working in a, so that you'll be equipped for a professional setting, right? When you are given a job, you know that, oh, I have to do this, I have to do that. Okay, I hope that's fine. All right, so it's it's 10 o'clock, but sorry we didn't start early. I was actually waiting for a couple of people to join and they were unable to join. So it's prolonged our meeting and all that. Sorry for that. But I will try and make a time within the week. I'll communicate it to you for us to continue, right? We'll have to finish whatever we have here, right? We have not done any of the visuals. I'm just taking my time so that we get everything bit by bit. So within the week, I'll speak to my co-executives, right, for them to allow me to have another session with you. Is that fine with you? Hello. Or
Yes, yes,
or
sir.
or we
Yes,
Yes,
should
sir.
cancel
Yes,
the
sir.
session.
it's
Yes,
fine.
sir. Yes,
All
sir.
right. Okay. So, what should I even do? All right. So the code you see here, can you maybe in the next 5 minutes I should be done. Right. So the code you see here, numeric columns, it's what it does is it only selects numeric columns, right? I want to select only numeric columns so that when I'm filling in the missing values, I can fill in with the numeric columns, right? And this one, it decided that if you fill missing values, you just use fill NA, right? So you call the column that you want to fill. So DF, then the column name, right? Then the column name. Let me just do it well. Okay, column name, then dots fill NA. So fill NA means fill null values or missing values. Fill NA, then you can either do the same column name, right? So this one, you fill it with the mean. If you want to fill it with the mean, column name dot mean, right? Then it will just fill it for you. If you want to fill it with the median, you can change it here to median. That's the same thing that is here, right? It's not much this one. It's nothing complex, right? Yeah. So first of all, we just select all the numeric columns, right? Then we fill them with the mean or median. Mind you, you have to check, right? You have to check the column, consult with your stakeholders. You have to check the mean, right? Check if there are outliers before you take some of the steps. You don't just fill it with mean or median, right? I'm just demonstrating it for you to understand that, oh, this is how we do it, right? But in actual sense, when you are working, you have to ask yourself, is this data having an outlier? If it's having an outlier, then it will mean that if I fill the missing values with an outlier, um, if I fill it with the mean, it will affect my work, right? Okay, I think I didn't say this. one thing is 10-4. I'm just concluding. The next time I meet you, I'll go over what we did. I'll just do a recap, quick recap. Then I would, what else? I'll continue with where we stopped from, where we stopped at, right? What I wanted to say is when it comes to outliers, outliers affect the mean. Mean is sensitive to outliers. Mean is sensitive to outliers. So the example I gave that your company is making 2,000 cedis every month, but because the billionaire came and his money was small, right now you move from 2,000, then your mean becomes 2 million, right? That's what I mean by the mean is affected by outlier, because the outlier is there. When you are taking the average, it will add more weight to your data set. That's why at times we don't advise people to fill missing values with the mean when there is, for instance, when there is an outlier, because the outlier will introduce more bias to your data. So instead of your mean being 2,000, the outlier will make it 2 million. And just imagine, you are filling all the missing values in your data set with 2 million, right? So that's very, very, very wrong. That's a wrong representation. The median is actually the middle value, right? So we just use the middle value at least to fill when you have a lot of outliers in your data set. I hope that is fine and clear. Hey, am I here alone or you guys are with me? Hello?
Yes, yes, please.
Okay. So that is it about outliers. Because I'm sure some of you have not done programming. So for loop and all those things, all these things are programming stuff. Everything we are doing here actually is programming stuff, but I'll do my possible best to go back to some of these things so that you can better understand whatever we are doing, right? So I'll end my presentation here, right? Okay, Franklin and quiz.
So
Let me
please,
start with Franklin.
how do we set up the Jupyter and the Anaconda and all those things?
Oh, okay, so that one you go to an anaconda download, right? You download it on Google.
Um,
From there, you should see anaconda installed on your machine. After installing it, you should see open it, right? At times they will require you to do some sign-in process, right? So you just sign in, then you install Jupyter Notebook. You see several packages, Jupyter Notebook, I think, oh, the other packages I don't remember, but you have to just click on install, then you are good to go.
So are they both how are they related? The both of them.
Okay, so Jupyter runs on Anaconda.
Okay, thank you.
Another hand is up. You can go ahead.
Please, I want to ask that instead of using the Jupyter Anaconda, can you use R or RStudio or PyCharm to do what you are saying?
All right. So, yeah, you can use R to do whatever I'm saying, but R is a programming language on its own, right? So, whatever I'm doing here, the equivalent can be done with different packages, right? So, everything,
Yes.
the pandas I mentioned, everything. with R, it has its own thing. Of course, I'm ggplots, dplyr, and other packages. But for our session, we are just using Python. So that's the only thing we can use. Python is
So
also an
You can
IDE.
use
Yeah, Python is an IDE. It's not. It's like a toolbox or a coding environment where you can code. Right? How Visual Studio, all those things
okay.
are coding environment you can use. And something is your hand still up.
Okay.
Did you? Okay. All right. So, any other questions before I draw the curtains to our meeting?
And so please, how will we get your this one, your number,
Uh
in
oh.
case of any
Yeah.
need?
You can contact. I'm on the Telegram page, the machine learning boot. I'm part of that page.
Well,
Yeah.
I'm
So
not on the page, so
really, all right.
yes.
You let me drop my WhatsApp number in the chat session. Right.
But
But
pardon?
you can be in touch with me on LinkedIn, right?
Please, I
LinkedIn
didn't
is
know what you
Awuah.
said.
All right. So I was saying you can reach me on LinkedIn, Isaac Jimiwa.
Link.
Yeah, or you are
Oh,
not on LinkedIn also.
LinkedIn. I'm on LinkedIn.
Yeah, so you can reach me there. I've also sent my contact in the chat section.
Okay.
Yeah, so on LinkedIn, Isaac Jimiwa, or in the on WhatsApp, you can reach me on 02571533791. Okay.
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 All right. So, is there any other
um,
question before I close the meeting?
yes. Using Jupyter, can we just use VS Code?
Come again.
Is everything that you did, can we use it? Can we do the same thing in VS Code instead of
Yeah.
Jupyter?
Yeah. What I did, you can do it in VS Code, but you have to download extensions, right?
Okay.
Yeah, you have to download Python, like Jupyter Notebook extensions in VS Code. So, so you can actually do it with VS Code, but you just have to download some extensions. Yeah, so that's it. All right. In the absence of any question, shall we pray and close the meeting? Can someone pray with us? Who volunteers?